one of the things you could be asked to do with a conditional statement is to define its converse, inverse, and contrapositive. So the first thing we'll have to do is we're going to have to define a conditional statement. As if P then Q. Depending on whether or not you've watched the symbolic form yet, you may have seen this. I'm going to read this again. This is read like this. So if P then Q. Okay, so we talked about this where we would make our hypothesis, the if part, a P, and the conclusion, the then part, a Q. So if that's what we've defined for a conditional statement, the converse of the conditional statement is defined as if Q, then P. So what that means is we're going to switch whatever the if part here was P, now our Q is going to become the if, and the original Q, conclusion, now becomes our if part. Okay, so those just get switched around. Alright, negate. Negate means to, like negative is the opposite, so negate, we read that as a not. First of all, we're talking about the inverse right now. The inverse of a conditional statement is defined as if not P, then not Q. So again, this little squiggle means not. So when we do some examples, you'll see what I mean by that. We're going to negate the P, the hypothesis, and negate the conclusion. Okay, and then the last one is the contrapositive. And the contrapositive, for me, that was always the easiest one to remember because it was the longest word, and I do the most work. I'm going to both switch, so we're going to go backwards this way, and negate. So it's going to become if not Q, then not P. Okay, so now let's look at a concrete example. So we're going to use the conditional statement, if it is snowing, then it is cold. So here's my hypothesis with my if, there's my conclusion with my then. I'm going to go ahead and use colors again for this. So it's snowing is my hypothesis, I'm going to call that P, and it's cold is my conclusion, I'm going to call that Q. So when I'm asked to first write the converse of this statement, what I'm going to do is switch the two. Okay, it's going to go backwards, so it's going to become if Q, so if it is cold, then P, so then it is snowing. Okay, next let's do the inverse. The inverse is, remember, when I negate them. So I'm going to go in the original direction, so the P then Q, but this time I'm going to negate them. And here's what I mean by negate. So if my P is it is snowing, my not P becomes if it is not snowing. Then Q, the Q was the second part, so it is cold. So then not Q, so then it is not cold. Okay, and then my last one, the contrapositive, I'm going to do both, switch and negate. So it's going to be if not Q, so if it is not cold, then it is not snowing. Okay, and before I go on, I want to say a couple things. First of all, the negation part. if your original statement, I'm just going to make up a new statement here. I'm going to actually do it up here. I'm going to say if I define R as I'm not hungry. Okay, well notice that the R has the not in it. I want to show you that if you negate that, what actually happens is you end up saying I'm not hungry, which becomes I'm hungry. So this is just kind of a little side note here. I just want to show you that sometimes you go to negate something and the original statement has a not in it. So when you negate it, you actually take the not out. And then the other thing I want to show you before we go on is I want to quickly talk about the truth value of these statements. Okay, so most of us can agree upon the first statement being true. If it is snowing, then it is cold. Yeah, that's always got to be true. So let's go ahead and put a true right here. Okay, how about the converse? If it is cold, then it is snowing. I'm going to go ahead and say that that's false. And I could come up with a counterexample. There's plenty of days in December, January where it is very, very cold, but it doesn't mean it has to be snowing. Okay, so that's a false statement. The inverse, if it's not snowing, then it's not cold. These get a little trickier to decide, but if it's not snowing, then it's not cold. This is also false because it could not be snowing, but at the same time be cold. Okay, so that's a false statement. My last one, the contrapositive, if it's not cold, then it's not snowing. Alright, well, if it's not cold, like for example, say it's hot outside, then it's not snowing. Yeah, that has to be true. Okay, so what I want to show you right now is that the conditional statement and its converse, so I'm reading this right here, the conditional statement and its converse, the first two, do not have to have the same truth value. They are not logically equivalent. And I just want to point that out because it is so common that we fall for this trap in advertisement all the time. When they take the converse and throw that at us, a lot of us decide, oh, that must be true. No, a conditional statement and its converse are not logically equivalent. They do not have the same truth value, not necessarily.